Hypothesis testing for a population proportion. In this video, we're going to look at the 6 steps that are used in hypothesis testing for a population proportion. First thing we want to do is state the null hypothesis, denoted H sub O, and the alternative hypothesis, which is denoted H sub 1, and sometimes it's denoted H sub A. We choose whether the hypotheses indicate a need for a right-tailed test, or a left-tailed test, or a two-tailed test. Number 2, we choose a level of significance. This is normally given in the problem. The default is alpha equal 0.05. And this is the probability of making a type 1 error. Number 3, we calculate the value of the test statistic. Now this is going to come from these 4 numbers. N is our sample size. X is the number of items in the sample with a certain characteristic. P hat is our sample proportion, which is X divided by N. And this is P null. This is our assumption of what the population parameter P equals. Number 4, we compute the p-value that comes from the corresponding calculated test statistic in step 3. Then we draw the region and we calculate the probability by using table 5, StatCrunch, Minitab, or a calculator. Number 5, we use the p-value to determine the outcome of the hypothesis test. It's one of 2. If the p-value is greater than alpha, our level of significance, then we fail to reject the null. Or the other outcome, if the p-value is less than or equal to alpha, then we reject the null and we conclude the alternative. So we have a saying for remembering this: if the p-value is low, H of O must go. P-value being low means when it's less than or equal to alpha. That's when we reject HO. HO must go, and we conclude H1. Number 6, we state the conclusion in clear English. Now this is what the 6 steps look like on handouts and on your test. So step 1, we state the null hypothesis and the alternative hypothesis. Now since this is involving proportions, this is going to be P equal to a number, and this will be P is less than a number, P is greater than a number, or P is not equal to a number. That will tell if it's a right-tailed test, a left-tailed test, or a two-tailed test. So how do we know which one of these we're going to use? Well, that comes from the alternative, and there'll be wording in the problem that will indicate which tail to use. Number 2, the significance level alpha will be stated in the problem. Number 3, this is our formula for the test statistic. It is a Z, and it comes from using our 4 values here. Once we have computed the test statistic using this formula, we go on step 4. Step 4, since this is the test statistic is a Z, we draw the standard normal Z where the mean is 0. We find the p-value from our test statistic. We draw that region on this picture, and we calculate the probability by using table 5 if you're doing it by hand, but you could also use Minitab, StatCrunch, or the TI 83 or 84. Step number 5, the p-value helps determine the outcome of the hypothesis test. If the p-value is bigger, is greater than alpha, we fail to reject the null. If the p-value is less than or equal to alpha, then we reject HO, the null, and we conclude H1, the alternative. If you can remember, if the p-value is low, H of O must go. You would reject H of O and conclude the alternative. Step number 6, you state the conclusion in clear English. So you'll see some examples of this, but somewhere in your conclusion you're going to see either there is sufficient sample evidence or there is insufficient sample evidence for the claim. Thanks for watching.